everybody ready? I know that they're reading a late this evening, just wanted to people start to filter away and rest of their stuff. But I strongly encourage you to stick around for Brendan. Brendan is absolutely terrific on DTrace. So when I was working with us, there were authors of DTrace. We knew about this crazy Australian who's doing things with DTrace that we had never imagined before. Then we realized that DTrace is a very difficult tool for everyday folks to use, and created the DTrace toolkit. We hired Brendan. Brendan wrote the DTrace book. He's the foremost user of DTrace, the lead performance engineer at Joint, and he's going to show us about DTrace on all platforms, including Linux. If people have questions that have come up through the course of the evening that have not been addressed, DTrace for Linux, for FreeBSD, for JavaScript, for Java, Brendan's already going to ask. So, Brendan.
Great. Thank you, Adam, and thanks for letting me, thanks to the LSP organizers for letting me talk here. And as Adam said, we're going to talk about solving problems with DTrace. I've used DTrace a lot since prior to its launch as a customer. And I regularly use DTrace on multiple different platforms. I've used DTrace and make the number one user of DTrace on Linux at the moment. There are two different components of DTrace on Linux. And it's been really helpful for us. I work for a cloud computing provider. We have a mixed environment. We have some Linux, and to replicate custom issues in the lab and solve them in Linux. So it's kind of fun. I've been able to get into the Linux kernel with DTrace and see how these work. I used to go into other kernels, and I've been in this last kernel for a very long time, and it's the kernel. And so it's something new. It's like a holiday. I get to go through a different kernel and learn new things. That's a fun. Some of you might know me as Shouting Guy. Has anyone seen that video? It's a viral YouTube video of me shouting at disks. A few people have seen it. It might be in the memory if I play it. I discovered that if you shout at disks, you can induce latency. And it was something that the hard drive manufacturers knew about. And I had emails, it was kind of funny on YouTube, they had comments from people saying, oh, it's a hoax. The guy's doing something crazy, he's bashing the disc with his hands. It's approaching 1 million views on YouTube. However, I had emails from hard drive manufacturers saying, yes, we've known about this for a long time. It's because a hard disk is a physical device and it's susceptible to vibrations. But it wasn't really publicly known until I did a video. And part of the video, I had a graphical performance analysis tool called Analytics. And at the top of Analytics is a latency heat map. And these corresponded to when I shouted at the disk. And with the latency heat map, I could see that I was actually causing an issue, a really serious issue. It was inducing multi-second latency going on the disks. And that latency heat map is based on DTrace. So DTrace is the back end, it was recording this, and it allowed me to understand latency in detail. It was really important actually because latency outliers were killing the benchmark that I had, and I was suspecting all sorts of strange issues. I debugged everything else. And with DTrace, I could examine all the IO in real time using Google. You've seen Max in the previous talk. Max likes to go down into deep details, we went into MGB, looked at some machine code and some instructions. You may not all need to do that. So some of you may actually get value from DTrace because you're an end user of a GUI like Analytics. And so when you see some of these really deep, and I'll talk about that a bit more, when you see some of these really deep examples of DTrace, it doesn't necessarily mean you have to do that yourself. You may be a user of a GUI that has DTrace in the back end. So DTrace platforms, DTrace has been shown on Oracle Solaris. I use it as part of my day job on the Linux kernel, which is the surviving kernel for Oracle Solaris. And that has distribution of SmartOS and OS. Mac OS X, so on my MacBook, I have DTrace. QNX. In development, there are plans for DTrace for Linux and Sony Vita. I am running one of the development versions of DTrace for Linux in a VM instance so that I can demonstrate it, and I'll talk about that more. Providers. So just to give you an idea of, here I kind of broke it down into mature development. With mature, I would mean DTrace works. It does what it says in the tin. You have no worries about running DTrace, just like you have no worries about running top, or ISDAT, or VMstat, or whatever. It's just another tool. It's part of your day job. You use it all the time. The development versions, they've been, actually I don't know about the Sony one, we don't know very many details. For the Linux one, it is in development and it can panic and freeze the code. So that's where I make the distinction. The mature ones, these are all mature, and these are stable. However, they do have varying number of add-ons or libraries provided. So those libraries are DTrace providers, and the DTrace providers, it makes it easier to go into JavaScript or Objective-C or Node or Perl, Python or whatever, go into the kernel into different areas. If you are on a kernel, then if you're in a kernel, the most providers will probably be a kernel like Lumos. The least providers will be one of the development versions of kernels. If you're on one of the kernels with fewer providers, you can use the dynamic tracing and capabilities to work around. So many of these providers, you can think of them as convenience libraries. They do make your life easier, but they aren't necessary. You can solve problems even if you don't actually have them. And just to finish what I mentioned to start with about DTrace users, just because it's really important, you can go into depth and it can be a bit off-putting. Some of you will like DTrace scripts, and that's fantastic. I've written lots and lots of DTrace scripts. I authored most of them in the DTrace toolkit. Some of you will use DTrace scripts, and that's fine. And there are many DTrace scripts out. I just mentioned DTrace toolkit. That's one repository of DTrace scripts. I wrote many in DTrace book. And if you're interested in a particular topic, if you're interested in Node.js, if you're interested in Ruby.php, generally if you Google PHP and DTrace, you'll find some scripts that people have written. You can take them and tweak them. So you might be that camp when you use some people's scripts, that's fine. And also, like being practical, being realistic, we find that in science, you generally have a team of sysadmins, you have an application development team, operations team, and there'll generally be one or two people who write the DTrace scripts, and everyone else uses them. So that might be something that helps you understand how this fits into when you go back to work. If you have a platform where you can use DTrace, you might not be the person that writes them, and that's fine. You might be the person that asks someone else to write them because you have a business need to measure performance or debug something. And of course, people use DTrace queries, analytics as well as shouting lists to demonstrate, but there's been several queries for using DTrace to get rich, detailed data in the system. And you might know these things, you might be a manager, you're not going to write DTrace scripts at all, but you need to know what questions you can ask people to write for you. So what's a sensible question? I know you've got, my staff can run part of my environment on these FreeBSD nodes, or on these Smartest nodes, or on these development Linux nodes. What questions can I ask my development team to answer? Because I need it for capacity planning, I need it for troubleshooting. So you might be one of these people, and that's fine as well. Whatever you do, you need to know what can be done, what sensible questions. Examples of one way to convey that. Actually, this diagram is one way to convey that. DTrace can see everything. So, kernel, I can go to the applications, I can go to different languages, and I can infer things that happen on hardware as well. And for example, a little bit of a plug for my previous book, which was called DTrace, it's over 1,000 pages. The primary operating systems for that book were the primary operating system was Solaris. And then I used Mac OS and FreeBSD to show how things are fairly similar over there. And I had a new book coming out, which I finished writing, so it's in the hands of the publisher. It's called Systems Performance. The publisher will be Prentice Hall, and primarily this is about Linux. and I'm using Lumos and SmartOS as a secondary operating system for comparison. And again, there are a lot of DTrace examples in there. There's also there's a lot of performance, perf events, Linux, some system tab. But there's also examples in there as well. So, using DTrace on multiple platforms, there are lots of examples out there, but it's not really about the examples. It's about the methodology that you apply to the system and the questions you want to ask. The examples are handy in their thousands, and I'm responsible for creating many of them, which may be good or bad thing for creating too many. But what you really need to get good at is, what am I supposed to do with all of this stuff? How do I approach the system? Once you understand the methodology, going and finding the tool is not the hard part. The hard part is knowing the questions to ask, and these are platform agnostic. And to go through just a couple of examples of methodologies, we want to demonstrate some DTrace on Linux. Let's take a drill down analysis methodology. This might be very familiar. And I'll talk about latency analysis as a methodology. So drill down analysis. This is the operating system stack. Sometimes when people say full stack, they're referring to just their applications. I like to think of it as everything from the bare metal up to where you're accepting network connections. So that includes the kernel and the file systems, the TCP/IP, and the applications. I might be starting off with a MySQL database, and I have high query latency, and I'd like to know where that originates from. With drill-down analysis, you can work your way through the stack. I've decorated, this is just a operating system's one-on-one diagram of what's inside the kernel. I've decorated it with example DTrace scripts that I use fairly often to debug this sort of thing. And so I'll start with the process level, and I'll quantify the customer pain. I handle, as part of my day job, I handle performance tickets. And so when there's a really nasty performance ticket, I have to figure it out. Often, the customer thinks there's an issue, but there's not an issue. So you want to confirm that to start with, and prove that there really is high query latency. Then I can go down to the system interface and trace that, and go to the VFS interface, because that's a nice high level across all the different file system types in that kernel context. Then I can go into each of the file system types. I've got a whole load of scripts in ZFS. Actually, ZFS is a great file system. Both Adam and I worked on it. One of the reasons ZFS is such a great file system is that it's always being developed with DTrace on hand. So anytime there's been a performance issue, with DTrace on. And so when you hear people talking about great DTrace performance, it's due in part because of its architecture, its design, its engineering. It's also due in part because it was always developed in an environment where we were all running DTrace. So there's loads of things to do with DTrace on ZFS. Block device interface, which has existed in Unix forever. That's what we see when you run IOStat. And there's lots of ways to investigate that. And then getting down to the device drivers. So for drill-down analysis methodology, prior to dynamic tracing, you use what the operating system vendor gave you, and you try to figure it out. I used to do performance consulting prior to DTrace, and I used to get paid some good money for what I call the art of inference. I'd be able to run IOStat, and VMstat, and MPstat, and be able to infer what the kernel was doing, because the kernel wouldn't tell me. I didn't have direct access to it. And that's how consultants made some money. Now you can just dig it out of the kernel directly. And so it's no longer this black box that you need consultants to figure it out. I can just write a script. If I want to know what the CIO pipeline is doing, I just write a script for the CIO pipeline. And I mention latency in the CIO pipeline. If I want to have ZFS, the overhead ZFS compression, just measure the overhead ZFS, just write DTrace script emissions, not many lines of DTrace. So it's an entirely different world now that we have DTrace inside the kernel. That's drill down analysis. Here's a different methodology just to discuss briefly and understand how you actually apply DTrace. This is latency analysis. And here's an example where I'm using DTrace, the front may be really small. I'm using DTrace to measure MySQL queries. And I'm printing out, I'm focusing only on the query string rate in 100 milliseconds. And I'm printing out the query time at 254 milliseconds. And I'm using DTrace to measure the time you were blocked in the file system. Has anyone blamed the disks for causing slow database queries? Well, what I want to do, like what's the ideal tool that I can prove or disprove that the disks have caused the slow database queries? Well, I can, like if it's my signal, I can dig through the perf, waveforms interface, and I can do that. The high-level question is, for that long query, break down the time of the query. How much time is spent on the CPU doing what? How much time is spent blocked on the file system and the disks, waiting for the disks? It's a very high-level breakdown. And that's what this DTrace script does. And it's just an example of something, it's what I try to do to solve problems. Once I can do this, 254 milliseconds per query, 209 milliseconds waiting for the file system. Well, it's mostly file system. The top one, 528 milliseconds per query, 509 milliseconds for the file system. It's like 90% file system. And of course, there's other ones that are different. I've got ones where I'm spending more time on CPU. Here else I print the IO count, so I can try and investigate if it's caused by. Maybe it's calling to the file system because it's just doing a lot of IO, and they all add up. Or maybe it's slow from the file system because you have an outlier. So metrics and helping us in that as well. Then I can drill down. So that's at the top level. Outliers, I feel it's one of these, 152 milliseconds for one IO. I spend a lot of my time chasing down latency outliers. As you can have disk events or network events that are in the seconds that really help performance. And they're really hard, if you're looking at averages, they're really hard to figure out. So in DTrace is creating these sort of latency distributions. This is latency, how to, and then I can look at where the bulk of the events are. And these guys down here, or how I'm going to catch the outliers. That's the ZFS stack, ZFS right. This is in the ZIO pipe. These are all the terminals of ZFS. And basically I can go down ZFS derivative layer, I can go to block twice interface, I can go to SCSI layer, I can go to mega scans layer. I can step through the kernel, just to give you an idea of what I'm doing to work on some of these issues. I can step through the kernel at different layers and say, what's the latency of this layer? What's the latency of this layer? And see if they correspond. Because if this guy, what's that? Gee, that's a 2-second IO. No, 268 millisecond IO. If that guy, and that's the mega SAS level, that's the device driver for accessing disks. There is this SCSI level, so working my way back up the stack, I can see it work its way up. There is a side at the ZIO level. This is ZIO weight. It's not the ZFS reads or writes. So I might have missed it there. But I can see if I can trace outliers all the way down to this device, it can be this device. If I can't, they vanish, then it can be lock contention in the file system, and it can be another source. But I'm using these distributions to root cause where the latency is originating from. So that's just a quick idea of the sort of investigations that we use. Now, this investigation obviously is not Solaris specific or Mac OS specific. This sort of methodology you can do anything. Those latency distributions are awesome. They allow you to identify outliers and multi-mode distributions. DTrace is very good at these because it has things like quantize and hell quantize and hell quantize. And you can also dump core event data analysis if you like. To give you an example of this, I did recently, what would be the disk IO latency, hard disk, so run SSD, for a mixed read-write workload? Mixed read-write workload, hard disk, let's say 10K RPM, they're going to be slow, 300 reads and writes, random reads. I could be looking at 5 to 8 milliseconds, something like that. This is the latency distribution that came out of DTrace. Generating this is actually used to ask statistics software, just use DTrace to gather the data. Oh, okay. This is a bimodal distribution. And I have one mode on the left, which is so fast that the latency on the x-axis is a histogram. this shows that I had many events with a very low latency, which is going to be disk cache hits. Then I had these events, which is my actual random reads off this. This is microseconds, so that's 6 to 8 milliseconds of range. This sort of thing is pretty common. So you get this from disk, you get this from any device that has cache hits, cache hits or cache misses. How many caches are there from your application to a disk? There's a lot. There's over 12. Like I did write them all in the systems performance book. There's terrifying how many caches for, let's do the de-entry cache and the disk cache itself, the controller cache, and we might have per-video caches. There's lots and lots of caches, and each of these caches generates a multi-mode distribution of hits and misses with latency. If you try to understand this with the mean or average, I actually plotted the average here. It's pretty misleading. The average is designed to help you understand a unimodal or normal distribution. So any distribution that has a single mode, but we often have multi-mode distribution. Not just devices that have cache hits or misses, but also applications that have a fast code path or slow code path. So anyhow, when you see things like this with DTrace, this is where we get really excited because we know how important this is, because we really do want to see the full distribution of latency, the full distribution of anything, to properly understand in addition to the average. I recently wrote up, it's kind of weird, but if you can picture, here's a latency distribution I had, I was working with. Again, this is my mode, this is disk latency. This is over, I think it's 2 minutes. If I look at it on a second-by-second basis, this is all the data is generated from DTrace. I'm kind of showing you the end goals of DTrace instead of like, I will get into the nuts and bolts, but this is the sort of end goals of using DTrace data. Plotting the second-by-second histogram of disk I/O latency, and I can see that actually this is not just bimodal, the modes move over time. And this movement of the, I guess I'll call that the minor mode, it's smaller than the major mode. That's what made this as over 2 seconds more spread out. 2 minutes more spread out, sorry. So this, if I can imagine taking each of those frames and converting it to a row of colors, and then I can rotate that row of colors and paint a heat map. And that's really things like this. I actually wrote this as it's just as open source software, it's on GitHub, you can code it yourself, you can enhance it. It will take any per event data and spit out a heat map. And why do I need to write it? It's because per event data, detailed data is very common with DTrace, because we can access it from anywhere. Here's an example. The heat map itself is actually an interactive SIG, so I can mouse over and figure out where the latency is and quickly understand the trace file that I create. So that's the sort of richness you can get out of DTrace. And again, you can get this from any layer of the stack, wherever you want, in applications, so that you're not trying to figure out where these outliers come from. Look at the distribution. Where's my performance? Why is it not expanding like I expected? Do you have a bimodal distribution? Bimodal distributions are great as a performance analyst because usually once I find the second a higher mode, I'll then filter that out and target that for analysis. Let's reduce that second mode. What is it about some of these I/O that make them slower? And then go back to DTrace and find out, oh, it's just got a different attribute. Do you need that attribute? Can you turn it off? And so yeah, very useful information. Now, one more graphical demo before I go to Ubuntu. And if you've seen me shouting at disks before, you've seen me demonstrate a GUI built on top of DTrace. There actually aren't that many. It's really, so if you're into performance monitoring, you're living at the right time because you can build DTrace into a product and have access to all this fantastic data. So some have been created. This is one we haven't used to join, and I'm a little terrified because I'm using software that was deployed less than 7 days ago, so this is all new, and it may be bugs, but it's fine. These are all the different things that we can do with DTrace. It includes things like looking at CPU, Node.js, network interface, system calls. Let's do discounting operations broken down by latency. I can break it down by additional details, but I will accidentally show customer information, so I won't do that. But this is something that we use as operators of the cloud to figure out where latency is originating. My windows are visualized in a funny way after plugging in the projector. This is a joint data center. We're a cloud provider like Amazon. This is a joint data center. I think there's probably a few thousand instances. And I'm looking at disparate latency across the entire data center, live, in real time, showing full distribution second by second. And I can investigate these high guys, these are the latency outliers. That column should make it easy to read the time in nanoseconds. I can investigate these high guys and the high latency and figure out if they're causing customer issues. And I can zoom into where the bulk of the latency is. And let's see, the latency is pretty low. In fact, I just told it to color linearly. So it was using false colors and many colors. Most of the items actually being out of cache. And I don't have any bad high load distribution number. But just to give you an idea of the end product of DTrace, because I know that the text demos can get a little bit deep, but it might help you understand what can you do if you have access to DTrace. You can build a product like this. DTrace is great for running 24/7. That's why Adam and I built when we were in Sun with the ZFS storage appliance. It uses DTrace for monitoring and generates heat maps. Customers have them turned on 24/7 by 365 in production, and they record latency heat maps at a 1 second granularity. It's all thanks to DTrace, and it's been designed to be low latency. So, my final demo of the end product. Then we get back to down into the nuts and bolts of DTrace. So I've got an Ubuntu image here. I set this up yesterday. I wanted to start with something fresh. So I downloaded the Ubuntu CD. I did the apt-get installed, some basic things I needed. I wrote about DTrace for Linux. There are two ports of DTrace for Linux at the moment. One of them is being developed by Oracle for Oracle Enterprise Linux, which I think is now just for Oracle Linux. And we've met with the engineers, they talked to DTrace last year. They actually seem to be on a pretty good trajectory. The engineers have a good focus on the DTrace test suite, which is part of why DTrace is so safe. It just works, it doesn't hurt production. And we're really looking forward to them releasing more code and getting it done. It is taking a while, and so I was hoping them to finish more stuff than they have by now. I don't know what's holding them up internally, there could be other projects. But I would celebrate the Oracle Enterprise Linux effort as making steady progress in the right direction, and all of us in the DTrace, Adam and myself and others in the DTrace community, we have talked to those guys about it, and it seems like they're on the right trajectory. It's just going to take some time. The other version of DTrace for Linux is written by mostly by one guy in the UK called Paul Fox, and he has put it on GitHub, and he's been slowly plugging it for a while. And that's the one I just try and demonstrate because I can get that running on Ubuntu. Ubuntu is very popular. This one can't be free scroll because it's still in development. This version I'm playing with, it doesn't have symbols, kernel symbols, which is annoying. I can probably get that fixed. I add my own fixes to understand. If you want, you can help with this work. We can help the other ones. As far as I know, both teams will welcome contributions. And let's see what. So I'm running this in VMware, and I'll have, this is my VMware window open, so I'll have this ready. Oh, it looks like I hit that. I'll have this ready, it's not going on the impact the system. That's what happens when I'm using development mix. So, DTrace myself this grows, just to make sure. It seems surreal, but I really have my hands on it. So this is the 3.5 kernel. I'm going to talk on the phone. I did steps I mentioned earlier. And it is furnished in the 360,000 rows, which includes things like the syscall provider. It's furnished in programs like the syscall provider, so I can look at syscalls, and the FPT provider, so that I can get into the kernel. So for example, this thing has some easy vocals. And DTrace has dynamically created the code points for all of these. They don't add overhead to the system when they're not in use, because you're just running the normal code. But you have to enable them to actually pay the tax. So let's try something else. So I will DTrace, and I will enable the system codes. I'll aggregate a code 5 gigs down. This is just going to count the system calls count. This is such a private system. It is quite amazing. I work on multiple operating systems, and it's not the same everywhere. I may have to read this. I didn't see that. Okay, first patch. I'm going to read this on the weekend. I don't want to do this. Because this should actually work. Good thing Linux is faster querying, but I'm determined to show you a Linux demo. So some background. We do have customers who have Linux performance issues, and I spent a while getting a version of Linux working with DTrace, and I picked Fedora. And that worked pretty good, and we were able to solve some decent custom issues by replicating them in the lab. And so I had to work around issues like this, of reboots and headaches, but the end result justified the means, because we were able to, as a really specific example, we run KVM so that we have 2 types of cloud virtualization. OS virtualization for zones, and then KVM for Linux guests. And for KVM, our network performance was not great. Network performance was maybe only 150 megabits a second. And I used DTrace in the guest kernel and looked up and down the stack to try to figure out why the network throughput was not so good. And we eventually figured out the problems. And the maximum throughput now is almost 1 gigabit a second. It's about an 8x improvement using DTrace on Linux in the lab, because we absolutely needed to do it. We really needed this thing. So when people say DTrace doesn't exist on Linux, it's like, we've actually used it to solve production issues already. I know it's the lab, it's not production, but we're making it happen. So maybe you want to just do the dash. Let's start again. You can actually see what happens when I boot the Linux, the DTrace kernel module is loaded. The way it's been developed is an entirely separate piece. It's not part of the kernel tree. And you download it from GitHub, build it, load it, and it's there. There it goes. And that was one of the design kernels from Paul Fox for his DTrace for Linux follow, was to have it as a separate entity. Now I can try something that should be pedestrian like this. So I'm DTracing all the system calls, I'm frequency counting code from. You can see there's a lot of Qtex, some fast mutexes, and other stuff that's going on. This is entirely interesting, but. That stuff works. Of course, DTrace, I have to isn't one of these old school tracing tools that, I don't need to do that. Not one of these old school tracing tools that traces every single event and gives you a massive output file that you then have to go to post-process. I can cook up my post-process, I can cook up sufficient post-processing in the kernel where it's cheap to do so, and then consume the output. So that's why just summarizing things in the kernel and having the output is inexpensive and does not cause performance overhead. Let's do something more interesting. Instead of that, let's do the kernel. So I'm going to trace all the HTTP functions, and now I've got, well, I type out for myself, I have HTTP file map, HTTP release file, HTTP get error, HTTP file open, and so on and so on and so on. I can pick up any of these. Let's say HTTP, I've never done it for HTTP LC. Let's do a printf. I'm just going to pick up all these functions and look at the timestamp in nanoseconds, and then the exact name, the process name, the course of the people. And so I can go and pick up a function, flip to trace.output because I want to know more about it. I might want to know how did you get called. Let's add stack to this. Also myself, is that okay? It's fine, it's fine. I added the kernel stack backtrace so that I can see how I got to calling HTTP/LC. And the kernel stack backtrace is fantastic for explaining why. And I can see that I went through system call file, syslc, BFS, HTTP4, and this DTrace is basically the end of the stack. Everything above it is a bug. This is one of those things they need to chop off. I should file a bug for DTrace. This is one of those things you do in past stacks. Is not just something Adam about earlier. We need to truncate the top stuff so it only prints the valid part of the stack. I've used the DTrace for Linux so much, I have to remind myself that it's unsafe because when I'm solving custom issues, I can step around the lines because I've hit them so much. I know how to actually solve the problem. Obviously, in the long run, you don't need to do this either. We actually fix my bugs, it's fine. But if you hear me telling you that it's unsafe, I'm actually reminding myself that it's unsafe because I can get for an hour without hitting anything else. Because I'm just bootstrapping around. Okay, so that's fine. What else can we do? Let's do. So I came up with some scripts to demonstrate just some functionality. And when I was building this DTrace for Linux, I was trying to get kernel symbols to work. And as part of the build process, I couldn't figure out where I was with that. It couldn't find the file when I was typing makeall. And it was complaining that it couldn't find the file that it needed. And saying, file not found, give me the name file. Well, what was doing was I need the full path name. Tell me the full path name of the file that's not found, and I'll go and fix it. And so I use DTrace for that, because DTrace can trace the open system call, and if it's not finding a file, it's usually because it's called open and open is failed. In fact, I have a script from DTrace toolkit called OpenSmooth, which all it does is trace file opens. And I can give it switches like my X for only print file opens. That'll do. And now if I type makeall, it's giving me all the details. Oh, thank you. These are the failed opens during the normal build. It's just searching line paths. In fact, if I drop that, I'll show you all the others. So you can see how it's switching between that was CC1 and AS, RN, SA. You can see all the different processes and all the different files that they're opening. And this is an important concept. DTrace is not tied to one process. This is not S-trace. DTrace is tracing the entire system. S-trace is come and go. That doesn't matter. So, OpenSmooth actually helped me figure that one out. To give you some other examples. troubleshooting request entry. When this was debugging some disk issues, then I needed to know the commands that were being set to the disk. And as it turns out, you can just pluck it out of the kernel function call. And so this is kernel function call. Go give me the codes. I can look up this. I can make the script more sophisticated and translate it for you and make it human readable. But it's a good way to figure out what commands types are being sent to this. I'm going to go ahead and enhance that, and I can fix stack traces as well. I think this one actually. So frequency counts. And so I can look at stacky commands. Those are the command codes, and then it shows me why the kernel is calling that stacky command. Just as another example that I was using. RW time is a script I was using to look at the time for, I had an XT4 latency issue, so I was debugging. And so I picked on the VFS level. I'm just giving you an idea of the capabilities of DTrace. You look at this script and think, oh, this is it's not that bad. It's fairly straightforward once you learn the D language. It should only take a few minutes. With RW time, I can measure, if it's something you figured out. So this is all file system types, including sockets, which is big. I should filter it down. All file system types, and I can look at the latency distributions, microseconds for writes, and the latency distribution in microseconds for reads. And that read distribution is really bimodal. You haven't seen these guys before. On the left is the value of the writing count. This is bucketizing. So it's basically telling me that between 2 and 16 microseconds, most of our events run. And right at the bottom is the other load. And so we have these, this is like 65 to half a second, 65 milliseconds to 500 milliseconds. I've got some outliers there. It's often the outliers, and identifying that's great, it's often the outliers I'm troubleshooting in more detail. And so as an example of that VFS law, this is actually a very similar script, but I give it an argument. And this is the argument of how slow must something be to be interesting. So I can have VFS slower and say 100 milliseconds. If it's faster than 100 milliseconds, I don't care, just don't tell me that. Anyone familiar with the MySQL slow query log? No one's familiar with that? Some people. It's great. It's a log that tells us it's slow queries, greater than a second, and continue that down these days. With DTrace, you can arbitrarily create your slow whatever log. I want my slow HT4 log, or my slow dcache log, or my slow TCP connect log, or anything. Anything that happen to be debugging. And it's especially good when a customer in the ticket says, sometimes my connections take 3.5 seconds. Great, 3.5 seconds. Look for anything greater than 3 seconds, and then I can filter it out from these busy systems. Nothing's happening slower than 100 milliseconds, except for the batch shell. VFS is actually tracing all file system types, including sockets, and it's getting key strokes out of batch. If I actually reduce that down, I will get everything, including like disk event, if I can do disk events. But here's like dead 0 to. So here's an example, like I lost the columns, but I'm also getting direction for points in 1 second. DD was doing reads and writes, and the so fast is 0 milliseconds. I can change the code to be microseconds or nanoseconds and the like. So, yeah, when I ran this, because I was just running this, creating this earlier, what the heck is VM tools? Anyone know what VM tools is? It's very strange. It's reading from the file system a lot. Someone else reads. Don't tell me. Let's see if I can find it out. With DTrace, I can do things like. So I can start by saying, right, take all syscalls, if I VM tools see what syscalls are you running? Like, oh, right. Well, that's stuff. Times, okay, and then read 100 times, call, which is probably related to read, close, opens. Let's look at what the reads are doing. With the DTrace Cisco provider, I can just look at Cisco very easily. If I want to understand reads, I can look at the return value, I can look at the file descriptor, I can look at the size. So let's go VM tools team and look at the file descriptor for reads. I0 is the first argument, it's running all the time. And it says, it's reading from file descriptor 5. And so then I can, it's too long for a demo, but I can dig out the file name, file descriptor 5 from DTrace. I'd probably just run LSOF or something. And then look file script 5, initialize, not around for whatever it's doing. I did catch it reading these guys as well. It's reading proc info, proc stat, and things that. I've only spent like 60 seconds looking at this. What is VM tool something?
It's going to be one of the two things. It's either the VMware toolkit that's applying on VM, or it's the hypervised version that's going to offer. The OS recognizes it's running under one of those two.
So OS recognizes it's running under hypervised, it's running the VMware toolkit, something using VMware. So, did VMware stick that in there, or did it freeze with
It's probably the last, it's probably the version.
Great, cool. I can like spend a lot more time digging into that. To give you some exposure to other ones, and then I'm interested to ask questions. Some of the other ones that I couldn't demo on this version of the two that do tend to be sold out include things like ext4 slower, where I'm specifically looking at ext4 I/O, and I can put out the latency, SCSI cache flush commands. These are retransmits. It's fantastic. I can pop those out of the kernel very low overhead because look at the script is very short. Because I can go into DTrace, do retransmit, estimate the entry, and pull out information on the IP address through a retransmitting through, and print out the stack backtrace of why the kernel is designed to do a retransmit, which is fantastic. Again, another thing that I use to answer these questions. DTrace is just another example tool that I use. To give you, I guess the last thing I'll do is, I think I should do this, but I don't know what will happen. Let's do TP send message. TP send message is the reason why I actually learned Stack so well is I'm using it to understand stack backtrace of how the kernel is doing its stack. And I can go up there and that's just truncated it, just stack so big. So I can see that we've got Cisco, sysprime, VFS, and so on and so on, up until our TCP send message. DTrace can trace all of these, and also arguments for the timestamps in nanoseconds. And so if I have a performance issue or debugging, I have a lot of scope to attack the problem. And let's just pick one of these at random that I have not DTraced before. Let's pick core sys select. Let's pick stock now. This is where you then go to say, I've got C scope for the Linux kernel. And I can then DTrace and examine these items to get more information about what's doing. Except I can't walk the details of the Linux working. But what's something that has an integer? This is actually fun. I will walk up and down the stack until I find something nice. What about Linux in this? I've never done that. Oh, science, I can do that. Science machine it. So now I count to 0, I'm 0, I'm 1, I'm 2, I'm 3. And now I can DTrace. bytes. So I'm kind of interested in characterizing the size of messages that I'm bringing through the ID stack. And so immediately going to go to a quantize function. Let's do some stuff so that it's been saving things. Yes. Yay! This is my bytes distribution for, I've never done this before, bytes distribution of going into IP, and the size of the messages, assuming that is the size of the messages, I actually have to read some really good to find out. Just some quick examples of DTrace on Linux is, there's a lot that doesn't work yet, but it has been pretty useful so far because I do have a Cisco provider, I do have FPT for looking at the kernel, I can time latency events, so I pick any kernel event and find out its latency. I can look at stack backtraces to find out why I got to places. I can look at simple arguments like integers, like I just did over there. More complex arguments, like walking through structs and things, I need to get some more stuff working on Ubuntu to demonstrate, but it is possible, I've done it before. Higher level things like getting into JavaScript and so on and so on, they require USDT providers and network as we done there. How does this compare to other Linux tools? I'm very familiar with SystemTap. I'm also one of the top users in the world. I'm also very familiar with perf events. Perf events also have dynamic tracing. Perf events is anyone use perf events? The Linux perf events. Linux perf events, perf command. Does no one use it? Okay. Kind of cool. Does have dynamic probes that you can create. It's part of Linux free. It's very easy to get running. It doesn't do internal aggregations like this and that I use so often. It is more of a dump and then post-process, not quite in real time tool. And so that kind of has a long role in it. Certainly better than nothing, so I can do some dynamic tracing with it. SystemTap is another thing that's better than nothing, but my experiences I've had mechanics with that as well. Which is really frustrating, so I can't use that in production to debug things. That's it. So, any questions about, I talked a bit about DTrace in general and methodologies I use. I talked about GUIs because I just wanted to show you some things that weren't text commands and simulate in the lab because I can't pay. And I didn't have any other patterns for the rest of that, except the first one. So, that was pretty good. Thank you. Any questions? Yes?
At DTrace, we take the state of the program is tracing.
Sorry, say that again.
DTrace, you take the state of the program is tracing, like change an argument.
Can DTrace change the argument? It can, if I deliberately want it to change an argument, there are actions like copy out, and people have done that for funny things in the past, like pretending that it's a different version of the OS, so the license keys work, and but for various reasons like that, which may not be recommended, but it has it's an actual copy out where you might have use on hand. Apart from that, by accident, and Adam wrote the USDT stuff, by accident, DTrace doesn't do this by accident. You have to say, yes, I want you to mutate the program.
Yeah, so in general, you can't change things about the program without explicitly doing it. You need to enable what we call destructive actions to explicitly say, disable safeties, I'm going to potentially destroy my program, and you can do that in processes, but not in the kernel. We kind of trust you to mess up your own room, but not to burn down the whole house.
Any other questions? Yeah, at the back. You have to share. That's fine.
You've given several examples of kernels to which this has been ported. Are there any general characteristics of facilities needed in the kernel to support this? Or is it arbitrarily portable and we just haven't gotten around to putting it on Android yet or whatever?
I'm glad you asked that question because there seems like we read when people comment on DTrace, we read the forums and threads, and sometimes people have this opinion that DTrace is woven into the Solaris kernel, and porting it to another kernel requires a lot of work and a lot of surgery, and unless it's part of the kernel tree, it's never going to work, and it's going to be really difficult. whole class, the way it's done that code is entirely separate. And this is also what some kernel engineering generally do. It's kind of CFS has also been designed. And each of these products have their own interface and then their own abstraction. And so they have an interface to call into kernel routines. And as part of coding it, you take that API and you find out how does it map to the destination kernel. And if there's bits you need to translate, you can do a shim or whatever you need. The Java is not woven in. The bits that are woven into the kernels are the trace points. So in Linux, they're called trace points. These are baked into the kernel. They come out of DTrace and they're used by things like Perf uses them, older facilities used to use them, DTrace can use them. DTrace itself, on the Solaris family of kernels, has its own probes in the kernel, which is baked into the kernel. But the thing that actually gets baked in is just a macro to say, this is a TCP connect, this is a disk start. It's really not much code. All the serious code is in a separate DTrace module that is a consumer of those trace points. And just on Linux, you've got multiple consumers of those trace points, DTrace, Syntax, and so on. So, to answer your question, what is involved in porting this to other kernels? It's just getting those interfaces right. There's a lot more work in actually the parts that DTrace consumes, which includes CTF, so that it can do symbol resolution and lookup, because different operating systems provide debug symbols in a different way. And this has kind of been a difficulty with Linux, because we have Dwarf, and it's not the same as CTF. People don't have it there by default, whereas on Solaris family operating systems, you have symbol data by default, because it's a different scheme, it's much smaller. And so those are the sort of kernels that have caused it to be more work than expected. But I hope that it's just a matter of time before we'll see it on Android and fully on Linux. I'd love to see it on Windows. I haven't seen it on iPhones, iOS. You can elaborate more on that topic as well.
I've seen that unicorn, guys.
So yeah, it should just be a matter of time. Yeah. Any other questions?
IO provider on Linux, is it anywhere close to being ready?
The IO provider? I was going to demo it, and I tried it. It's like, this is DTrace in the wrong place entirely. It was DTrace in VF as well.
As Brendan was mentioning, the IO provider, the only difficulty with the IO provider is identifying the right place in the kernel to place that probe. That's kind of a manual effort. So on this particular port, it may or may not be the right place. In the Oracle Linux port, it will put the right place. It will have more control over what's going on in the kernel.
So yeah, it's just a matter of placing the program. And it's really not much work. It's just one macro that put the wrong place and she put somewhere else. Like, I went to demo and it's like, this doesn't make sense. It's just matching and stuff. So we need to do it. Yes?
Each has to be like DTrace much money. Or the other way, what is the least basic for you?
Go ahead.
No, feel free.
So the earliest place you can use DTrace, there is a facility called anonymous tracing, and so Sun developed that. So did you know? Brian developed that so that during the boot phase of the system, you can ask the kernel beforehand to begin tracing very, very, very early on with those modules, so that you can debug problems as device drivers. I've used it before when I had a laptop with a Wi-Fi driver. They were just do crazy things on boot, and I rolled DTrace script to actually show me the state while the device driver was initializing, and then I was able to drag that out.
So the short answer is when device drivers are when modules are first loaded. And for example, with Solaris or Illumos derived kernels, you can specify which modules you want to be loaded first. So there's a little bit of crap between grub and module loading that is invisible, but you can trace the rest. And you can create effectively a custom flight data recorder. Say, all of these events that happen, trace it to some buffer, and then once userland comes up, I'll pull down the information that was in that flight data recorder and find out what happened. Or, if you panic, pull that over for crash time. Other questions?
So I'm curious, what are the ambitious DTrace
work with you, but have not yet get time to hear it.
Ambitious DTrace projects. I would love to DTrace Firefox. And like actually DTrace it to death and find out every single latency bubble, every single performance issue, and use it as a case study of like, this is actually going as far as you can go with DTrace on an application. Because with Firefox, the bugs are all open, people can browse it, and people can use it as a very good case study of DTrace. Unfortunately, my fantastic effort with DTrace is often with particular custom issues, and a lot of that isn't made public. And so we don't have it as a public reference for people to learn. But it's an ambitious project. I love to DTrace Firefox to death and like figure out everything that's going on and improve its performance by a significant and impressive margin. Another thing is DTracing, what I'm currently, particularly what I'm currently working on right now is DTracing the interstack latency of networking and really squeezing every single nanosecond out of the kernel TCP/IP stack by watching its packets move through it. Complicated, because the kernel TCP/IP stack is pretty complicated, but it's an ambitious project. My problem is when you start DTracing that, you're drowning in data because you're pushing stacks and millions of events a second. And so I would like to take that data and visualize it, maybe using heat maps, or I've done all sorts of other visualizations to really squeeze the most out of TCP/IP, more than I already have to. So those are the things that come to mind.
So my DTrace Kickstarter is going to be a little different. I have this fantasy of being able to get types for userland processes in the same way that we have types for all of the kernel facilities. Which it might sound trivial, but there are whiteboards and whiteboard pictures filled with information on that. Then I'd also say that what DTrace supports these dynamic languages, as Max and Brendan and I have alluded to. It was, and there's a facility called User Level Static Fine Tracing that really enabled that. That facility was a bit of an accidental fortune in that it gave us so much access to these dynamic languages. But if I had to do over, I would redesign it with dynamic languages kind of foremost in our minds and figure out ways of getting type information and fine-grained method, function, procedure access, and bake it very deeply into the core of a lot of these dynamic languages.
In the example we just made on KVM, and fix that, is that still a general version of KVM?
Now, yeah, we've got our own, it's open source, but we're on our own tree now, and as far as I know, we're running different options for KVM. But from what I've seen by browsing forums, network issues on KVM have been pretty common, and I haven't seen people root cause them like what we did. And it's one of the hardest things I've done with DTrace. We were glad when we had running on SmartOS as a host. I was using DTrace in the Linux guest. And so we could DTrace the interaction of both of them to figure out the latency. And we may be some of the only people to really do this. I keep meaning to write this up as a blog post. I'm known for writing very long blog posts, but this particular one is going to be enormous. This is an enormous amount of work. This is very important as well. And just to summarize what the issue was, KVM was supposed to coalesce interrupts so that it could gather them together and pass them between stacks more efficiently. And there was a bug in how this was being configured and used, and it just wasn't coalescing packets properly at all. And so actually identifying that and getting it fixed is how we're able to drive through the way up. But yeah, we're happy to share this because obviously anyone using KVM is, if they're using that, because there's different ways of doing networking and however, if they're using the same type that we're using, they should benefit from this.
Any last question? All right, well, thank you very much. It's been a great evening. So thanks all speakers. And Brendan and I, Dan, and others will stick around.
Thank you all. That was really great. Great to see you all again, and we'll hope to see you again in June.